Hello, my name's Relevant. Welcome to the show. This is Do All the Things. On today's episode, another train lighting video because I'm going to be installing an EOT device on my Cabeese. If you've been following the comedy, you know that I tinker with the model trains there, and I also like to DIY my own circuitry. Today's going to be no exception with an EOT. If you are in the train hobby, you probably have a couple of these puppers kicking around, the Cabeeses. They're cute. You like to put them at the end of your train just to finish things off, but they have a major problem. And that is if you're running a more modern consist like your well cars and whatnot, these don't go. They stopped using these in the 70s. They were phased out by the 80s. We don't use Cabeeses anymore. We don't have to. We have automatic brakes now. We don't need people to run around on the top of the cars and manually turn on the brakes. That's a whole story in and of itself. But anyway, you still have a bunch of Cabeeses. You still want to run them, especially if you like primarily running modern trains. What are you going to do with all your Cabeeses? Well, I figured out a way to have my cake and eat it too, with the Cabeese. It's basically a flat car that I mount a Cabeese on. I actually have this scrap CN Cabeese that fits on there nicely. It kind of snaps onto these little nubbins that are there. I got this flat car in scrap. It was dirt cheap, and it had this assembly on the top of it with kind of like these wheel raceways, and I'm not exactly sure what they're for, but if I cut off the center nub, I found I could sit a Cabeese on there just perfect, and the other nubs stop it from rolling off the car, and it stays on there nicely, doesn't derail, it behaves itself. So now I can put this thing at the end of my consist, plop a Cabeese on it, and I could have a Cabeese on a modern train. Because even though a modern train might not be running a Cabeese, well, you know, we could fathom a scenario where some old scrap Cabeese is being hauled off for scrap to the scrap yard to get scrapped. Now, what is at the end of a modern train is an EOT, and I don't know that they're very flashy, but you know, the ones that we put on our model trains because we like to bling them out are flashy. To answer that question, I got a Details West ET277, and it was a bit of an enigmatic thing because it's just like this little piton right here, which is supposed to fit onto your coupler. Kind of like that. You're supposed to add glue and turn it into a dummy coupler, but yeah, that's how that's supposed to work. The instructions go on to explain how you sit it on there and how you're gonna remove this, install that, drill that. There's no actual hole in this thing for the light bulb. You have to add your own hole, glue it in place, blah, 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 get a flasher circuit, hide some wires. Yeah. This hails from another era, like I imagine pre-internet, in that if I searched this up, I wasn't really able to find a whole heck of a lot of information on it. I wasn't able to find instructions or close-up views of how it looks when it's done. It's the kind of thing you don't know what you're getting until you actually have it in your hands. So I didn't know what to expect. At $2.25, it's not much of a write-off, but it does come with a little red bulb. So, a flasher circuit. Well, that's where I come in because I like to DIY that kind of stuff. So I have a homemade flasher circuit. I'm going to connect it to this 9-volt battery to simulate track voltage, and you're going to see the bulb is blinking. It is an incandescent bulb, a filament bulb. Kind of underwhelming. It's not particularly bright. It would have been nicer if it was an LED, but I think detail accuracy, it's not going to be super bright, so it should be fine. Sadly, I can't get an LED that small that has wires on it. So here we have a very simple flasher circuit. So how does this circuit work? Well, right here, our track power comes in. We have an SD 103 Schottky diode. It's an upgrade from a normal diode. It has lower voltage drop. Diodes suck like that. Whatever voltage you put in, you're gonna get less coming out. It's usually like 0.6, 0.7 of a volt. This one's only dropping like 0.2, 0.3 at this current load, so a little bit of an upgrade. I have provisions for two 1000 U capacitors in this design, but I found in testing we only need one. If I disconnect the battery, you're gonna see the bulb keeps blinking for a not insignificant amount of time. So we can have a sketchy connection to the track and we're still gonna get consistent performance. From there, we go through my old buddy, the LP2950-30 3-volt low dropout voltage regulator. Low dropout means it can work at lower voltages. These guys have circuitry in them. They need power to run. At a certain too low voltage, they're just going to stop running and stop conducting. So this thing's not going to kick on at like the lowest crawl speeds. You got to get the train going a little bit before it starts working properly, but once it's working, it works more consistently. Now, if you're just going to run one LED in say a locomotive, I just use a resistor. I use this in the more complicated situations where I need a consistent voltage, and that's what I need to run this. After that, we have 4.7U post filtering, and then my good old buddy, the Schmidt trigger inverter. Today's flavor, a 74 HC1G14. That little guy right there, rated for about 6 volts, 20 milliamps. It can operate this little light bulb or an LED directly, and that light bulb actually is about 20 milliamps. So, and what's the Schmidt trigger do? We set up something called a relaxed oscillator. So a Schmidt trigger, if you put in positive signal, you get a negative signal out. If you put in a negative signal, you get a positive signal out, hence inverter. So basically what we do is we connect a resistor here, mouth to arsehole, and boom, it causes a feedback loop. When this output is positive, it feeds back, tells the input positive, which switches it to negative, it feeds back, negative switches it to positive, and this is what causes our blinking action. The speed of it is delegated by the size of this resistor and the size of this capacitor, because this resistor will resist the current flow. It will slow it down as it slowly fills this capacitor, hitting the voltage threshold that starts the change, and then the change happens, it slowly discharges the resistor. Now you're going to notice in my design, I have somewhat of an uneven blink, kind of like a strobe where it's mostly off and then we get blink, blink, blink. If we just used one resistor, we would get an action like this, where it's kind of on and off for the same amount of time. Actually, that seems uneven. It seems on for more time now. So we create a duty cycle loop by adding this diode and another resistor. The idea is diodes are, as we know, one-way valves for electricity. When this side is outputting negative, it can't go this way. It can only go through that resistor there. But when it's outputting positive, it can take this path also. It can go through both resistors, having that impedance and speeding up the switchover process. So by calibrating that, we can kind of get a lower duration blink, something more in along the lines of what we want. So today's flavor, they're big chunk boy resistors. They are 15 meg and a 10 meg. Those aren't as common values. They're more specialty, but if you're ordering from DigiKey or Mauser, you can get them no problem. 1/4 watt metal film. I do also believe they're 1%, so they're good ones. I'm using huge resistors so I can use a tiny capacitor here. Normally this would be more like a 1U or more to get this kind of slower flash rate. But by using huge resistors, we can use a small capacitor that also, because it's so small and because theirs is so big, there's very little current. Obviously, the smaller that resistor value is, the more current can flow here. It's going to conserve battery power. And then of course, bulb out. Simple circuit, as simple as it can be, aside from the regulator is the only really complex thing going on here. But how do I install that onto this car? Well, with some good old-fashioned perf boarding. To my old tricks, my good old tricks, I got a perf board here, yeah. I found that a 3x7 centimeter perf board sandwiches quite nicely underneath here. And by using components as small as possible, it is possible for me to build a circuit under here that will hide under there in this cavernous area. Now we will need to cut up this assembly here to accommodate this board, but well, that's all part of the fun. So for this, I have devised the following layout. Ta-di-da! Now this letter here and this letter here correspond to letter markings on here. It's labeled A through to X. So we don't need the whole perf board. And well, we need to not have the whole perf board. We're gonna have track forward positive. That is, this will be positive when it's going in the forward direction we want it to operate. Coming in from this side, there's reasons for that. There is our first diode. Our big capacitor, well, it's a bit big to stick on the board. So the idea is, in the section at the edge of the board that I cut off, it's gonna hang off the board like this, and then that should just fit underneath here. So that comes in, goes to the voltage regulator. The voltage regulator looks like this because it too is going to lay down on the board. Then our 4.7U capacitor, we might actually need to move that down a bit because our 4.7U is also going to have to lay down. And then boom, power crosses over. There's the inverter, there's our speed cap, if you will, and there's our little cluster. It's a little tricky here because we're kind of layering these over top of each other to save space. So from the output, it goes into our 15 and our diode. 15 returns directly to the input. Diode goes to the other side of the 10 meg, returns here. So that diode's going to be underneath the resistors because we needed a path to get to the lamp positive output. Track negative comes in here, lamp negative comes in here. The fact of the matter is, if you look at how the schematic works, the negative bus is all the same. The negative directly connects to the track. So I might not actually connect the bulb to the board. I might connect it to the power truck, directly to the power truck. So that's the reason why I put track forward negative and on the same side as the lamp. Now you're probably wondering, why is this so weird with this big gap here? That's because I'm trying to make it work around this bar. So the circuit is going to be on either side, and I'm going to try to maintain as much of this bar as possible. My plan is to go in from the top. So I'm going to nip away at this part until I can sink the board into the assembly, hopefully sitting roughly right about there, and then still have this crossbar over top of the board. That way, when you look at the car from the side, it still looks normal. So to start this party, well, we need to do some fitting. We need to cut this guy down. Did I ever try trimming on one of these boards with tin snips yet? Oh boy, I just discovered something new. Wow, okay. I have learned a new way to cut on my boards. You've seen it here, right on camera. I just looked in my tool shed, my tool drawer, and I'm like, hey, I wonder if I can cut a board with this. So we got to cut right at N, right here at N. How accurately? A to N, there we go. And I want that to fit between these two rails. And yes, A to N fits in here. And then there's space here from L and M. I was trying to be able to salvage this bar here, but that might not be possible. So it'll fit mostly in there. So I need my little side snips. We're gonna have to like cut out these brake cylinders here, which is too bad, so sad, unless we kind of go this way and we can keep that one. I don't know, which brake cylinder do we want to cut off? Obviously we're gonna have trouble stopping this train once we remove its brake cylinders, but I think one car without brakes is gonna be okay, right? Because the cap's gonna hang off here, and there's gonna be nothing here, so we can kind of leave whatever the frig that is. Honestly, it's gonna be easier to remove these guys. So here we go. Snip, snip. And then all these guys gotta come out. Right. And then we gotta start trimming on these guys. And now we have to make room for the board under here. So we gotta start trimming chunks out of here, quite like this. Oh, careful though, it looks like we're gonna start just straight up breaking this thing off. And we take little square bites. It's great how this goes flying across the room, never to be seen again. Until one day you step on it and we broke that whole one off. Okay, noted. Because now we need to be able to recess this by quite a margin. So I gotta start getting all this off. I need a different way to nip at this. Might have to come in straight here. Yeah, that works. Now, from about here to here, we have to get a chunk of this bar nipped out. I think that's just gonna entail a whole heck of a lot of nibbling here. This is a half diagnostical. Half figuring out how to make this work without like ruining the whole thing. Maybe if I do a corner snip here. Ho ho ho. How dangerous is this? Peel it back, eh? Oh boy. Okay, no rhyme or reason, just a bunch of nipping here. Eventually, that should work now. We will have to nip a little bit more once we install the circuit to compute how much clearance we need for what's running under the board. Yeah, definitely, I can tell you right now, we're gonna need a bit more. How are we looking now? That looks like still that one section where this hump is. It's hard to really get that down to where we need it to be. That should be good there. All right, well, let's get on to the circuit board itself. Now that we have our format, let's solder on this thing. 74 HC1G14 affected by the microchip shortage at the time of filming. But I'm using one specifically in the SOT 23-5 or a 5T SOP. That's important because they come in different sizes and some are too small to handle. But that's what I have here. Gotta get that out. Gotta get that ready. Ah! Oh, they're so small, they're hard to handle. All right, that's a BOB00717 adapter. And we got to get ourselves some Rosman schmoo here to solder that on. We'll use our finest tip. Tin those pads, get that plopped on there. And this is very delicate work here. But it's not as hard as it looks. In today's case, I've already put it on not straight. All right, we got it just roughly sitting on one side on the other side. Pressure, rake, 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 rake. It's a sloppier install, but it should work. And I take a toothbrush, alcohol, brush off the flux, put a piece of paper towel over it. Do one of these, needs a little bit more. And she's clean. Yeah, she's a little bit half cocked here, but she's still on there good. And before we forget, I'll mark pin 1 because it's hard to see. It's really hard to see. And that's all the flux we need for this. All right, let's get the board here and let's get giving her. And now we engage in a perf sesh. So this should work now. Positive power input here, negative power here, and just generally lamp out here along with negative. Let's see if we can test it. That hopefully should be making a connection so that if I get some positive to here and negative here, there she blows! Yeah! It's gonna work. It's gonna work. Now we just have to get it mounted. So generally, that idea is it's going to sit in ear. Oh, the diode. The diode's right under there. But I seem to have made enough room. And then all this is going to slat. Okay, that is on the coupler side. That's going to be the blinky side. So we got to put it this way. Just press fit that into there. Oh, our cap is coming up. I should have given it just a bit more lead. Oh boy, gotta move this down a bit. You know what? I think that actually fits better than I planned. How low profile? Look at that. How much stuff sticking out? Oh boy, it's pretty darn good, bud. The plastic sitting flat. Oh, this fits better than I expected. At least for now. We still have to insulate things because right now that's right against metal. Obviously that's not gonna work. We need an insulating layer here. I just planned on using hockey tape, to be honest. Now let's see if it still fits. Yeah, and that shouldn't short out and it should stay in place. Not even gonna really need glue. So the hardest part now is we need power pickup and we need wires. So for power pickup, I'm using Kadee Vulcan trucks. Their claim to fame is that they have the coupler boxes mounted on them. And I got these to try to be able to retrofit onto cars that don't have coupler boxes on them. Some can't have them. This one, I guess I could, because I could screw into the metal, but I didn't want to. So I just got these, plus these fit nice. The way the screws are, the screws that came with it were like this with that little bushing on there. And they fit perfect, bud. So what's special about these trucks is they're almost completely made out of metal. And I did test it. If you put metal wheels instead of the stock Kadee wheels, hey, you can electrify the truck. So if we solder a wire to the truck, we should be able to get power off of it. But first, the trick is to put metal wheels in there. So you're gonna notice these are some Rapido metal wheels. They're good wheels. They seem to be as good as Intermountain. One side of the wheel is swaged onto the pole. So this wheel, when it gets power, is gonna put power through the axle. But the other one has a plastic bushing. They have to insulate one wheel on a metal axle or else they would short out. So we have to take the non-insulated side and put it on the power pickup side, the truck facing this way, and it's already oriented the right way with this. So get that on there. So yes, this will pick up power from this side and transfer it into the truck. But we have to get a piece of wire soldered onto this. Some way, somehow. Well, that means this board is backwards. We need to rotate it because positive would go here, right there. So we have to get a wire through this bulkhead here. And while we're at it, well, we're gonna need to get power connections to these two bulkheads here. So we'll drill holes in them too. So I don't necessarily have the most adequate wires for this. I use these that I strip off a CD-ROM cable. Now they are solid copper, which they're tiny wires. They work well for this, but solid copper is gonna break after a while. So I'm not sure like how good of an idea it actually is. Now I'm hoping some way, somehow I can solder to this. Other than the coupler box itself, there's nothing plastic on it that can melt. So we'll take that off. That's assuming, I don't even know if I can stick solder to this. I'm gonna assume that I can, and I want it somewhere at the front. But I think this is some sort of paint, this blackening. So let's try to stick a wire onto it. All right, so we gotta get the workpiece hot. That's the thing, this assembly is gonna sink a bunch of heat. You know what, that's not sticking. We maybe have an in right here. Can we scrape off a little section here? Can we get a solder to blob onto there? Uh-oh. This is not boding well, sir. Especially our flux gets burned out before we can get heated to the workpiece. We might need some flux. If I can't solder to this, it kind of derps out my whole plan. See, like, you should be able to solder to it, but you have to get it hot enough for the solder to want to stick to the metal. So you need to transfer a whole bunch of heat into it. But this is not boding well. What is this material? Oh. Just as we're starting to melt the mounts. Okay, this is, I think we gotta take the truck apart before we ruin the springs. Yeah, one of these springs started getting overheated. Either way, let us attempt to move forward by getting it all hot all again. Okay, yeah. I've definitely got solder to stick to it. It just takes a lot of heat to get it there. Now we gotta try to get a wire soldered to that. Yeah, a piece of wire that's gonna break off in no time, right? Oh yeah, we totally have a weak spot there. All because a set of powered trucks is gonna cost like $30, which is frickin' ridiculous, bud. Frickin' ridiculous. It's essentially their trucks with a wire attached. So that is a wire attached. We should be able to get power from this now. That's one truck. We gotta find the spring I dropped. Oh, there's one. Gotta find the spring I lost. BRB. While you weren't paying attention, I soldered onto the other truck, so it's ready to go now. Soldering to these is actually a massive pain in the arse, and I'm questioning whether or not it's something anyone else can do but me. I had to try several techniques. I didn't bother filming it because it's so experimental. It's like, I just can't recommend this anymore. I gotta figure out how to make this work. But nevertheless, there's wires on it now, so hopefully I can get that in there. That has to connect to right there. So it's gonna wrap around a little bit, which is okay. These holes are maybe a touch small for this wire. Looks like these wires might get cut by the wheels if we have too much radius. Now we just have to attach it to this line here, which I guess is gonna be floating to some capacity. Ideally, I should have ran these wires up the middle. Whatever, I'll redesign it later. Actually, if I pull some slack here, just push that down in there, it should be okay. Yeah, that wire's totally gonna get chowdered. Doesn't necessarily have to sit flat. It can go, there we go. That'll be okay. I feel like this is an overly fragile design. I'm not too impressed by it. Now, the hard part, getting that tiny little frickin' bulb in there. So first of all, I don't want to use one of my good couplers. So I'm gonna set that aside. It's only because these are offset ones, so I kind of want a way to be able to take this on and off. But I think it would be very difficult to do so. Like, the bulb has such flimsy little wires that it's kind of like, how do you even work with that? Like, one of these has to get extended down to over here. That has to go into here. We need a hole there so it can peep through. Well, there's actually quite a bit of meat in there. I don't think I quite have the right size drill bit. Huh, oh boy. It doesn't even sit in there nice. So I'm taking a larger drill bit, making this a bit deeper so that the bulb can fit deeper and maybe peep out the front a bit. Carefully watching the end. To get a feel for drill bit excursion. Oh, that's better. Now it goes completely in there and does stick out the end a little bit. In which case we should probably seal that over. This bulb doesn't keep popping out on us. What I'm hoping I can do is kind of wrap this wire here so when it comes in contact with the metal coupler. Okay, so I think I'm gonna fill that with some glue and then I gotta take a break for dinner because this is, this last part. Building the circuits is fun, but this part, not so much. So we're just gonna let that glue dry. All right, let's see if we can get this done. So all I could think of to do is I put one of my IC socket things. I glued it to the side of the coupler box here. So that's hopefully how I'm gonna get positive power to the light. I'm gonna put a socket pin on one of the light leads. For the light itself, I got one of those crummy Bachmann Easy Make couplers. Don't wanna use a good one. I've tacked a bit of glue on there. Hopefully it's gonna stay put for now. And we even have the light bulb in place. So, how to get this going? Well, I need to solder a wire to this little connector here. That connector needs to get cut down by a margin. Doesn't need to be that long sticking out. Kind of have to figure out what geometry I want this wire to run at. Like, do I want it to come around like this or just directly off? So we could kind of get this little piece of wire around the back nubbin. Everything has to get done with tweezers. Oh, maybe I should have cut it after I put the wire on, eh, bud? Oh. And my glue's still wet. This thing just came loose. Wonderful. Okay, well, the wire's on now. This is the final little bit of assembly. It's also going to be the trickiest aspect of assembly because we have all these tiny, tiny little bits to put together. So I'm hoping I can slip this under here, locate the corresponding screw, get that screw started. But here's the tricky part, which I don't even know if I have enough excursion to do this. Because what I kind of wanted to do was take the wire for the light and get it around this screw like that. Hopefully the screw still has enough bite. Of course it doesn't have enough bite. Why would it have enough bite? It couldn't have given us properly length screws. Looks like it's got to stay there though, except it's pulling a bit. I think it just needs a bit of coaxing. No, we need a slightly longer than this screw. That's about that size. We also need a little bit less lead. Because the idea is this entire truck is picking up negative. And the negative is all in the same bus. So if I can get that wire just touching on here somewhere, then it'll be able to pick up power from the truck. Ugh, all I need is for this screw to be a little bit longer. That or I need more propensity for bite. Okay, so we gotta do a bit more gluing, because what I do when I need a little bit more bite is I will smear the hole with some CA internally, some glue, to make it a little bit smaller. Just, you know, don't get it on the top here. So yeah, that's the most frustrating part of the process now. We gotta wait for glue to dry. Okay, well, pause again. All right, it's got to have been at least a solid hour now. Hopefully, now the glue's dry enough, we can put this pupper together. Yeah, should be okay. Home stretch. Don't fail us now. Gotta get this in the coupler box under there. Line up these holes. Find my little screw. Hopefully we've made that hole small enough. Our screw will have more bite now. Yeah, it seems like it's possible. This thing's just so loosey-goosey in there. I don't like it. Get the lamp lead under the screw. Some careful surgery. Okay. Tighten it up now. Oh, still not good bite, but it's there now. And it's not twisting it too wampus. Now for the other lamp lead, part of the plan, so we got a pin inserted here, or so we hope. It's like we need a little bit more insertion force and I don't want to break it off. Okay. So that pin's got to get trimmed down a bit. Do you mean to tell me that glue's still not freaking dry? Oh, how long is it going to take to finish this? Did I mention how much I hate glue? Yeah, no, it's totally not glued into place yet. It's been an hour. Still not glued. Now what I'm fixing to do is get this last positive wire onto that pin. Except it's somewhat tricky because, like, I don't want these wires just hanging out everywhere. I can't really let them touch. Oh, it baffles me how stiff this is. It's like really testing my dexterity to install this. This should roughly work. You just have to route on this wire, similar to the other one. Yeah, okay. Just some little precision stripping. Get this connected to this totem. This should work now. This side should be positive, this wheel, and this side should be negative. Ah, so I'm touching negative to this wheel, positive to this wheel. And we have a tiny little underwhelming blinking light. All that work for just that tiny little underwhelming blinking light. Well, I got a big bright light on it. Oh boy. Wow. And there we have it. It's delicate. It's probably gonna break and fail. In fact, I see the screw has already disconnected the wire. We got some bugs to work out, but it looks like it's gonna work. But either way, I hope you enjoyed this. I'm done here, even though it's not quite done yet. I just have to work out some kinks and test on it. But yeah, stay tuned for more. I think I have a little bit more train circuitry I want to build. So if you like trains and circuitry, wow, what a pain in the arse.